Well, hello and welcome back, mathematicians. We are just going to wrap up this idea of dividing decimals by other decimals by looking at what happens when you have decimals with different place values. Okay, so we said that it's important to think logically about these, and if you can get a picture, to get a picture in your brain. Well, we also said that sometimes these pictures are a little bit difficult to look at. But in this case, we have a situation where we're asking ourselves how many 4/10ths are in 96 hundredths. Now, don't let the fact that their names are different fool you. All right, so let's look at this on a little in a little bar model. Okay, so if we divide this bar model into tenths, and I'm not doing it exactly, of course, I'm just doing it roughly. All right, so this is a bar model divided into 4 pieces, and we have 4/10ths here shaded. Okay, and at this point, this is 9/10ths, right? If we thought about it as a kind of a bar model number line, right? Each of these would mark out a tenth. So this would be on a number line. That would be 1/10, 2/10, 3/10, 4/10. This middle line here would be 5/10, 6/10, 7/10, 8/10, and this line here would denote 9/10, right? And so on a number line, if we turn this bottom piece just into a number line so we can visualize both at the same time, 9 and 5/10 would be about right where I put this dot right here. So 9 and 6/10 would be about right here, okay? And we're asking ourselves how many of this 4/10 piece is in 9, if this is 0 on our number line, this would be 0, 96/10, okay? So this is our whole right here. And you see that there's one 4/10 piece, and that brings us to 1/4. And then another 4/10 piece would bring us to 1/8, right? And then I have a little bit more. It's not quite, not quite 2/10 more. So it's going to be about a little less than 2.5. So my estimate is that there are about 2.5, a little less than 2.5. This is going to be my answer. Just slightly less than 2.5 4/10 in 96 hundredths. Okay, so that's my estimate. And I have a good picture of it in my head. I've explained why that's reasonable to myself to say there are about 2.5 groups of 4/10 in 96 hundredths. Method 1 is to use fractions. All right, so let's start with 96 hundredths. Remember, you've got to put 96 over 100 because there are 2 place values here, tenths and hundredths, and we're dividing it by 4/10. And when we do that, I'm going to just move my problem down because of my drawing. We like to multiply by the reciprocal. So here we have 96 100ths times 10 over 4, an inverse operation with an inverted fraction, right? Here's the inverse operation, and here's our inverted fraction. And then we can simplify. 10 goes into itself once, and it goes into 110 times. 4 goes into itself once, and it goes into 96 24 times. Okay? And so our new problem, we're going to multiply across numerator and denominator. Don't pay attention to that. we're going to go 24 times 1, and that will give us 24. And for the denominator, 10 times 1, that gives us 10. And 24 divided by 10 is 2 4/10. And you see that my estimate was somewhere less than 2.5, and I have 2.4. So 2 4/10 is a reasonable answer. There are 2 4/10 groups of 4/10 in 96/100ths. Okay, so that's a reasonable answer. I like that one. But there's a different way to do it, and that's to make the divisor a whole number. All right. And so how we're going to do that is we're going to rewrite our problem. This is 96 divided by 4/10. 96/100ths divided by 4/10. And to make our divisor a whole number, in this case, we have got to multiply by tens. Okay, but I can't just multiply by 10. I have to multiply by 10 over 10, which is 1. And that way the actual value of this division problem does not change. We keep the value exactly the same by dividing it by, or multiplying by 1 in this case, okay? So when I multiply by 1 in the form of 10 over 10, I'm going to get 9 6/10 divided by 4. Now notice, my numerator is still a decimal. But my denominator, my divisor, that's the number I'm dividing by, which is 4/10, has become a whole number of 4. And I can rewrite this as a division problem. And that division problem is going to look like this. 4 dividing into 9 6/10. Okay. And of course I have my decimal here. I have got to move that decimal up. And now I'm going to leave it and pretend like it's not even there. 4 goes into 9 twice. Okay? 2 times 4 is 8. I'm going to go ahead and do my subtraction and bring down that 6 right next to that 1. 4 goes into 16 4 times, and my answer is 2.4 or 2 4/10. And like I said before, it is perfectly reasonable. All right, let's try a different one. All right, I would like you to do this before I do it on page 92 in your textbook. And I also want you to think logically about it. Give yourself an estimate. How many 6/10 do you think are in almost 8/10, right? How many 6/10 are in 78/100ths? That's almost 8/10. Okay, so 78/100ths. I can call this 6/10 plus 1 8/10. Right? So there is 1 6/10 here, and there is, this is almost 2/10. And 2/10 would be a third, so it's a little less than a third, but we're going to say it's about a third. So I'm going to say that there are about 1 1/3 6/10 in 78/100ths. That's my estimate. Go ahead and work the problem and see if you can find an answer that's reasonable. All right. Hope you've worked that problem. If you haven't, please pause and go ahead and do so. But here's method 1. And method 1 is to use fractions. 78/100ths looks like that, divided by 6/10. We don't want to leave it like that. We're going to say 78/100ths. Use an inverse operation of multiplication instead of division, and an inverted fraction of 10/6. Use that reciprocal. And then we can simplify before we get going. There's 1 10 and 10, and there are 10 10s in 100. And we can also simplify the 6. There's 1 6 in 6. And how many are in 78? Well, if I don't know this off the top of my head, I can break 78 apart. Okay, and I'm going to break it apart into 60 plus 18. Okay, I know that 60, this is the same as 6 times 10. And this is the same, 18 is the same as 6 times 3. So there's 10 plus 3 sixes in 78, and 10 plus 3 is 13. All right, you can check my math, but it's true. And then I multiply across, and I get, I multiply across, and I get 13 tens. 13 times 1 and 10 times 1. All right, 13 tenths. So then when I do the division, I get 1 3/10 is my answer. Now, I just want to say that 1 3/10 is a slightly smaller number than 1 1/3, which was my estimate, but it is reasonable because 1 1/3 would be 1 33/100 or thereabout, and I have 1 3/10, so it is pretty close and was a good estimate, and my answer is reasonable. All right. Now, the second strategy is to make the divisor a whole number. And we've done that in the last problem. We're going to do it again. All right, the first thing we do is write this as a division problem. 78 hundredths divided by 6 tenths. Okay, and I want to make that a whole number, that divisor. So what do I do to do that? Well, if you said multiply by 10, you're right on the bottom. Well, whatever I do to the denominator, I have to do to the numerator because I don't want to switch the value of the entire fraction. So I want to keep its value the same and its relationship the same. And so therefore, I'm actually multiplying by 1 in the form of 10 times the numerator and 10 times the denominator. And I get 7 8/10 divided by 6. So now my divisor is a whole number. I'm going to rewrite this problem as a regular division problem. Now, what do I do? The question is, what do I do with this decimal point? I'm going to move it straight up, and I'm going to leave it there, and then I'm going to divide as if I have no problems. All right, so 6 goes into 7 once. 1 times 6 is 6. Subtract it. 1, bring down that 8. All right, 6 goes into 18. 3 times, I get 1.3. And that is a reasonable answer because it's very close to my original estimate. All right, I'm happy with this. Oops. Yeah, so far so good. All right, let's try another one. How many 3/10 are in 6 75/100? Well, trying to explain the meaning to yourself, obviously very helpful in this. And if I drew myself a picture, I could say, well, it's hard for me to do a number line, but I can do a picture. And I know that there are 3/3 in every whole number. And I have 6 whole numbers. So I'm going to say 6 times 3, which is 18. All right. But I know that 3/10 times 3 is actually 9/10. So I'm missing a tenth for every whole number, and there's 6. So that means that there are going to be another 2. Okay, that brings me up to 20. And in 75 hundredths, 3/10 and 3/10 is 6/10. That's another 2. So I'm going to say that my estimate is 22. That's my estimate. All right. I think it's going to be just a little low because 3/10 plus 3/10 is 6/10, and we're talking about 75 hundredths, not 6/10. So, yeah, it's going to be a little low. My answer is going to be higher than 22, but not much. Not much. All right, let's try method 1. 6 75/100. Oh my goodness. Well, this is a mixed number. And you know that every whole number, in this case with this denominator, 100s, is going to be 100 100ths, and there are 6 of them. So 6 times 100 gives me 600, plus 75 100s left over here is going to give me 675 100ths, and already it's looking like a little bit of a hairy mess. dividing that by 3/10. And of course, when I divide, I need to multiply by the reciprocal because that makes my life loads easier. So our new number, our new problem becomes 6 75/100 times, using the inverse operation and the inverted fraction, 10/3. All right. And I can pre-simplify this. Now I could do 6,750, just multiply across by 300 on the denominator and divide, but that's so much work and I don't want to do it. So I'm just going to simplify first. There's 1 10 and 10. There are 10 10s and 100. There's 1 3 and 3, and there are 225 3s and 675. I know that because there are 200 and 600 and there are 3/4 and 75. All right. So now my new problem is 225 times 1, multiplying across, I get 225. And 10 times 1 is 10. And when I do this division problem, my answer is 22 5/10. And it is reasonable. It is reasonable. Do you see that? I said a little over 22. And sure enough, 22.5, great estimate. I'm very happy with my answer. It's looking good here. All right. How am I going to work this with my next method, which is to make the divisor a whole number? So I'm going to start with 6 75/100, and I'm going to divide that by 3/10. Right? And I'm going to make my divisor a whole number. I'm multiplying by 10 to get that to be a whole number, but I can't just do it to the denominator. I've got to do it to the numerator. And so my new problem is 67.5 divided by 3. And I'm going to rewrite this. 3 into 67.5. All right, 67 5/10. And what do I do with this decimal point? Well, I'm going to bring it up. I'm going to stick it there, and now I'm going to divide like it's not even there. Okay? 3 is going into 6 twice, and 2 10s times 3 gives me 60. And so then I'm going to subtract that, and I get 7 left. And I know that there are 2 3s in 7. 2 times 3 is 6 again. If I subtract, that leaves me with 1. I'm going to bring down that 5 and deal with that. 3 into 15, it goes 5 times. And so my answer is 22.5. Still reasonable, still the same answer, and we're good to go. Well, that's all I have for you on this practice of making the divisor a whole number and using the power of estimating to predict an answer, to explain meaning to yourself. And sometimes it's just helpful to draw a picture for even one part of it to help you, kind of figure out what is a reasonable answer for this problem. And if you know a reasonable answer, it will prevent you from making many, many mistakes. All right. Well, we'll see you then in the next video. Thank you very much for watching, and